Okay, we're going to have a look at something called a residual plot. So, we've been looking at least squares regressions. Okay, a least squares regression is something that looks like that. Okay, but it assumes that the relationship is linear. So if you go and get the calculator to work out A and B and do up something that looks like that, you're actually assuming that the relationship is linear. There's two ways you can check to see if it actually is linear. You can graph it and take a look, or you can do something called a residual plot. So we're going to take a look at what a residual plot is today. Okay, so here is what a residual plot looks like. Basically, what we've done is we've taken the regression line that describes this set of data over here on the left, and we've spun it on its side and we've made it go flat through 0. And then we are measuring how far the actual pieces of data are from what the regression line predicts them to be. So the residuals, and we've talked about residuals before. And then it plots what the difference is over here. So we can see that this point, if I go to, what's a good one? If I go to x equals 2, if I go up, there are 2 pieces of data on x equals 2, one above and one below the line. So if I go over here at x equals 2, this shows me how far above and below the line they actually are. So what are we looking for when we look at a residual plot? We're looking for random. Okay, if the data is spread out randomly around this line here, then that tells us that the line of best fit, the regression plot, is actually appropriate. It's good. It's suitable. Okay, we would expect all of the data points to be evenly distributed around. That would be as opposed to something that looks like this. Have a look at this one. See this pattern that we see here in the residuals, where it's a curve. Okay, if you go and match up over onto our one over on the left-hand side, you can see that the data starts off on this side of the line and then starts moving over this side above the line and then ends up back down below the line. And the residual plot makes that really clear. Sometimes it's not super clear. The residual plot allows you to make it really clear because you can fine-tune this axis on the side. And if you see a pattern in the residual plot, then a linear regression isn't appropriate. Okay, something non-linear like a quadratic or an exponential might be better. Okay, patterns can look like all sorts of things. It could look like a wave, or it could look like that. Okay, or it could sort of go like that. But what we really want is something that looks like this guy here. So how do we go and make one of these? Well, what you do is you do exactly what I just said before, is work out what the actual data is and take away what the predicted data from the regression line is, and then put that onto the graph. So let's just jump in and do one. So here we go. This here is car age versus sale price. So I'm immediately going to go, this is the EV and this is the RV. Okay, so I would expect to construct a, wrong way, I would expect to draw a plot that looks something like that. Okay, with my EV on the bottom. So I'm going to have, this is 0, 1, 2, 3. Oh, let's spread it out a bit more. I'm going 0, 1, 2, 3, 4, 5, 6, I'm running out of room. Let's try again. And let's do a nice one here. 1, 2, 3, 4, 5, 6, 7, like that. Okay. So 0, 1, 2, 3, 4, 5, 6. Nice. Now what I've got to do is I've got a 0 mark, okay, which I will do in a sec, because what we want to know is we want to know what the predictions are, and that will help us work out what scale to put on this side. So let's look at the predictions. The regression plot, that was the regression line that was made for this data, is this. Okay, the price equals $35,100, take away $3,940 times the age. Okay, so that is the equation for that line. Okay, someone's gone and plugged this data in, worked out what A is and worked out what B is, and there we are. So to work out what the residuals look like, I'm going to do the actual. This is the actual data, and I'm going to do take away the predicted data, and that's going to give me what goes here. So to start with, to work out what this value is, I'm going to replace the letter 1, or the number 1, for age. Okay, so let's go ahead and do that. I'm going to do the price equals 35,100, take away 3,940 times 1 for the age. Okay, and I'll go and do that on my trusty calculator. I'll get it out of the way. So 35,100, take away 3,940 times 1. And that tells me the residual, or the predicted value, is 31,160. So the actual data point at 1 is this, but the line for the line of best fit is telling me that it's this. Okay, close, but not exact. So let's go ahead. This one's not going to change because the X value is still 1. Now we've got number 2 for the age. So down here, I'm going to replace the number over at the end with the number 2. And that's easy on the calculator. I can just scroll back, delete 2, and there's the predicted value from the regression line for a 2-year-old car, 27,220. So let's go and put that in, 220. Okay, now I'm going to do the 4-year-old car, so I'm going to scroll back and do 4, 19,340, and now this is 5-year-old car, 15,400, and last but not least, the 7-year-old car. Scroll back and I'll chuck in 7,520. Cool. Okay. Now what I want is I want to do what the residual is. Okay. So I need to add another one. What's the residual? So the residual is the actual take away the predicted. So let's do it. For number 1, we've got 32,500 take away 31,160. Okay, that's the sale price. That was the actual data we had. Take away what the prediction is. So our residual is 1,340. Pen. Go black. 1,340. Now I'm just going to go ahead and do the rest. So I'm going to go 30,500 take away. And if you have a look at this one's negative. Okay, so that means that the actual data is less than what the line predicts. So that's negative 660. And I'll go and do the next one, 26,500, take away 27,220, negative 720. Okay, and 22,000, take away 19,340 is 2,660. It's a big residual. 2,660. Okay, 16,000, take away 15,400 is 600 in the positive. And last of all, 6,400, take away 7,520 is negative 1,120. All right, so now I'm going to pick my scale. I'm going to put a 0 line here on my residual plot, and that represents 0. So let me get rid of that. Okay, that's 0 there. And now I'm going to decide what to do, plus and minus on each side. So I'm thinking because of this value here and how big it is, we might have to go up in 500s. So this would be plus 500. This would be plus 1,000. This would be plus, I'm actually going to move the 0 down 1. Sorry. Let me put the 0 down a touch. We only need to go to 13, 15,500 to there. I'll do one higher. How about there? Okay. So that's my 0. And we're going to do plus 500, plus 1,000, plus 1,500, plus 2,000, and then up here is plus 2,500, and that should do. And then down here is where we go the negatives. So negative 500, negative 1,000, negative 1,500, negative 2,000. Cool. So now we've just got to go and plot those things on. So at x equals 1, we've got a residual here of 1340. So I'm going to go and put that on. Okay. Go up at 1 and go up to 1,340, which would be sort of here. Okay, can you see that one? And then at x equals 1, I've also got a residual here of, so that's car age is 1, negative 660. So I'm going to go and put that on. At 1 is also negative 660 there. And then I'm going to go across to car age is 2. The residual is negative 720, so I'm going to go to put that on. That's going to be about there. Car age 4, residual is 2660, so that's up here. Okay. Car age 5, the residual is 600, so that's going to be just over there. And car age 7, the residual is negative 1,120, so that's going to be 1,000, about there. Okay, so that is our residual plot. Question, is it random? Or can you see a pattern? I'd say it's pretty random. Okay, I think it looks pretty random. You've got an even scattering over it. You've got, say, one that's a bit further out, but there's no really defined pattern like what we saw before. So we would say that a linear regression is suitable for this. Okay, and that's a residual plot. We use it to decide whether a linear model is appropriate for a certain set of data.